A parking guidance system is a technology-driven solution designed to help drivers find available parking spaces efficiently. It utilizes cameras and software algorithms to monitor and manage parking spaces in real time. The system provides drivers with accurate information about the availability of parking spaces, guiding them to vacant spots and reducing the time spent searching for parking. The main goal of the parking guidance system is to optimize the utilization of parking spaces, enhance traffic flow, and improve the overall parking experience. When a car enters the parking area, the system's camera detects the car and captures its type and number plate information. The captured information is then processed using YOLO V8 based deep learning algorithm to identify the car type accurately and extract the license plate information. We employ the YOLO V8 deep learning model, known for its robust object detection capabilities, to classify car types based on their sizes. The system is trained on a diverse dataset containing images of various car types and sizes. The dataset is prepared using RoboFlow, where 4,044 images of different cars are labeled as SUVs, mid-size SUVs, sedan, and hatchback. The number plates of all these cars were also labeled.
We fine-tune the pre-trained YOLO V8 model on our dataset and optimize the hyperparameters to achieve accurate and reliable car type classification. To detect the license plate, the YOLO V8 model is employed. Once the license plate is identified, the system crops the image to isolate the license plate region for further processing. ECOCR, a widely used optical character recognition library, is then utilized to extract the number from the cropped license plate image. ECOCR provides efficient and accurate text extraction capabilities, allowing the system to retrieve the alphanumeric characters present on the license plate. Based on the identified car characteristics, the system's parking slot allocation algorithm comes into play.
The parking allocation code is designed to allocate parking spaces for cars based on certain conditions and constraints. The algorithm first validates the information it has received by checking if there is duplication on car number, and it validates if the car number ensures the standard format. Then the code iterates through each parking lot and checks the condition to allocate a parking space for the incoming car. The conditions taken into consideration are: if the car is an SUV, the code checks if there is already an SUV parked in the neighboring spaces. If so, it skips the current space and continues to the next space. The code keeps track of the number of SUVs already parked in the parking lot. If the SUV limit has been reached, that is around 40% of the total space, it skips the current space and continues to the next space. If no suitable space is found in the current parking lot based on the conditions, the code keeps track of the vacant space of the same car type encountered during the iteration. A car leaves, the corresponding parking space is made vacant, and this vacant space is given priority for future car allocations. These conditions ensure an optimal allocation of parking spaces while maintaining their defined constraints. The parking space of each vehicle entering is stored in a database. This database assumes status as variable 1 when a car is parked and 0 when the car leaves. A camera in the exit is used to detect the car number and the type of the car exiting the parking lot. When a car leaves the parking lot, the status of the car is changed to 0. A GUI has been created using tkinter, which helps in monitoring the parking lot. Tkinter is a standard Python library, meaning it comes bundled with Python installations. This seamless integration allows developers to leverage the full power of the Python alongside tkinter to build GUI applications.
So this is the GUI hardcode for the implementing the CSV and for monitoring purpose. So now we load the CSV file to visualize the parking lot system. So this is the parking lot where the 4 vehicles are parked near. And if the mode is set to be leaving, the status will be updated to 0. So let me change this. Now we have run the model for the leaving mode, and let's check the CSV. So now the status has changed to 0, and we now check the parking lot system through the GUI. So again we load the CSV file, and we can visualize the new parking lot after the vehicles have left. So the parking lot is actually empty because all the vehicles have left. So this is the monitoring implementation of the parking lot system.
Implementation of parking guidance system is crucial in high demand areas to address challenges posed by increasing vehicle volumes. PGS optimizes parking space utilization, improves the overall parking experience for drivers, enhances operational efficiencies for business, and contributes to sustainable urban mobility. Furthermore, the data collected by PGS presents opportunities for future research and analysis. By analyzing parking patterns, occupancy rates, and user behavior, valuable insights can be gained to inform future infrastructure planning, traffic management strategies, and urban development projects. These insights can lead to a creation of smarter, more efficient parking facilities and optimized transportation networks.